Hi, welcome to Beyond the Download Count, understanding the usage of your public Python packages. My name is Avi Press. I'm the founder and CEO of Scarf. So before we start, just a quick note about these slides. They're generated from an org mode doc, which both the source and this PDF is available on GitHub, so feel free to read on your own time, open up any issues, or even pull requests. So first, let's talk about Python registries as they exist today and what kind of data they provide maintainers. Overall, Python registries are way, way ahead of other programming languages when it comes to what data we provide maintainers. Same goes for system packages as well, but things still could be better. So when we look at Python or PyPI, you can query all of your downloads via Google BigQuery. And so you can query the timestamp of each download, package version, installer name, and Python version. There used to be even more data offered through PyPI, but this is currently what is at the hands of maintainers. Other registries offer more and less. So Conda does a really great job here, offering information on also the data source and platform associated with any given download. GitHub Packages and Google Artifact Registry are a little bit less granular, so you can kind of just get downloads by version and then the total for your package. AWS Code Artifact, a similar story. You can get the total as well as that time series, basic time series information, but at the aggregate level with things like CloudWatch. But we might want to understand quite a bit more than that. One really important thing is understanding uniques. And so overall, like the total download count is a very, very noisy metric to have. If you had 10 downloads, did that come from 10 people, or was that one person downloading 10 times? These are very different numbers. We also might want to know the downloads by what country they came from, what architecture that they were run on, what companies were behind the download, or other details from the user agent that we might want to understand. But ultimately, downloads have a lot of data in them. The registry can see a lot of information in the headers. There's also a lot of information just in the time series of how packages are accessed. So when, for instance, someone runs a pip install against a registry, the registry will see a whole lot of information in the headers. One is the IP address of the client. And then the other, as we see an example of here, pip has a lot of information about about the user. So for instance, what CPU architecture, the distro and operating system, Python version, how even Python was installed, OpenSSL, and these sorts of things that can give a lot of information about the context that our packages are being used in. So this has we can start to get a notion of uniqueness with the IP address and with these headers. In that metadata, there's a whole lot in there that we can use and to further contextualize these downloads, and it can really give us just insight into how these packages are being applied in the real world. So again, that notion of uniqueness, just knowing you had 1,000 downloads doesn't really tell you all that much, especially if it, say, only came from 5 distinct sources. And without any notion of uniqueness, it's really, really hard to contextualize any of this. And so that's what's really, really missing here. IP address metadata is also very fundamental here. So like, where are your users in the world? If you were going to translate your README, what would be the next best language? Are the downloads coming from companies or individuals or laptops or CI, and which clouds? The platform and client also has a lot of information, especially because a lot of downloads on PyPI actually come from other registry mirrors. Being able to tease those out is very, very helpful if you're trying to make sense of this information. I think a lot of people may be surprised to see that a lot of those downloads come from very few sources. There's a really great blog post from an open source group called Linux Server, which does a lot of Docker packaging, but some of their containers were downloaded a ton, but not from very many people. And you'd never really know that unless you're tracking this notion of uniqueness. But when we look at what else can the registry actually see, one thing that's really interesting is kind of the time series of information when you also have this notion of uniqueness. The whether you're checking the registry versus downloading it, what you're downloading, the frequency and spacing of these things can give a lot of clues into the behavior that you're trying to understand better. So if we consider this access pattern where we have the same source of the traffic is checking the index of Django to see, basically if you're running pip install on Django, the client is first going to check the index of that package to check all the available versions, and then it will eventually pull down one of the wheel files so it can get the rest of all the things that it needs to build the package. And then in this trace we see very regular intervals where we are checking for the index at simple Django, and we get a 304, the registry telling us that we already have what is latest here. And so the relevant info here is that we see highly regular intervals where the client seems either be rebuilding or polling for the latest version, but not really doing anything else other than checking. And so we could make some guesses at possible explanations for this traffic. It might be a production deployment. It could also be an internal tooling deployment, but something here is likely very automated. And that automation has context, it has a cache. And the headers are persisting, and the registry is very good at telling the client, like, hey, there's nothing more you need to do. You're all up to date. Let's look at a different example where we see someone, they fetch the latest version of Django. They're checking for updates at fairly irregular times. They then fetch an older version of Django. They downgrade, they do some more work, and then they go back to the latest version. And the relevant info here is just that we see, there's irregular intervals, there's multiple versions. This looks like a person, and a very likely explanation is that there's some local development going on with Django. And so, if we're convinced, okay, this is useful data, but how do we actually get it? Well, there's a few different things we can do. So one is that we can you can try to convince the registry to give you more access to this data. Let me know how it goes if you try this. I think this is one of those things where there's lots of requests for different kind of data. The registries are many, and they can really only do so much of it. And without the proper funding, it's really hard to actually make some of these things go through. But that doesn't mean we shouldn't keep asking. Another option that we have is to host your own registry. That is, you can point your end users to a registry that you control. So instead of just running pip install your package, your users could run pip install extra index URL to a domain that you control, and then your package. This has some pros in the sense that there's open source solutions to do this, like DevPy. So you can just spin one up yourself without a whole lot of headaches. You can also then start to distribute your Python packages from your own domain, and then you have pretty much full access to whatever you want to do with the data that hits your servers. But hosting a registry is not an easy thing to do. Bandwidth is pretty expensive, and really, the availability and performance are totally on you. If you have users on the other side of the world, making those downloads quick for those users is not easy to do. Keeping things available for those users at all times, also not trivial or cheap. But another idea that can be put forward here is a registry gateway. And the core idea here is that we are going to put a service in between the end user and the registry, just something that's sitting in the middle, and just passively passing the traffic on to wherever it needs to go, but then capturing some of the information of the traffic that flows through. And so this has a lot of pros here in the sense that the gateway itself can be a very lightweight service. It can largely just redirect and be very dumb. If the registry changes its API, the gateway can be fairly robust to that because it's largely just passing data through. Doesn't really have to understand the API behind it. The fact that you can redirect rather than proxy means that there's very minimal bandwidth overhead, and even can decouple you from the registry behind. You can start to move where the registry actually sits, but the gateway itself acts as a static endpoint here. It can even work for things besides Python packages, which is very cool. Obviously, there's some cons to this, which is that we're really adding complexity to the whole stack here. And it's a new failure point, a new performance choke point, and so these things can't just be taken lightly. These have to be added carefully to your stack should you decide to go this route. But overall, it's very simple. You just, with a little Nginx config like this, we're just going to take some new domain, we're going to listen for HTTPS traffic, and we're just going to rewrite everything we get over to PyPI. It's almost that simple. So the gateway actually does have to proxy and rewrite requests for the registry index so we can ensure that the artifacts that the client actually fetches go to the gateway first. So there's one very small addition there, but a lot of the complexity just comes from the infrastructure side to this. The gateway needs to be fast, it needs to be available globally, and doing that is not trivial and is a lot more than just the business logic of the code that you're writing. You then obviously also have to process your logs and store data properly. That's not trivial to do. There's also a lot of volume. And then on the client side, there's some quirks, especially around extra index URL, which I'll get into. So, the idea here is that, if you consider this requirements.txt file, you have one company that has its own index that's using, another organization has theirs, and we're going to pull packages from both of those registries as well as PyPI. And so the question is, for any of these packages, where will pip go to install the package? Well, the answer is we don't know. This behavior is undefined in pip. They do not want us to assume where something is going to go just because we've supplied an extra index URL. And so if the client ends up going to the wrong registry, you're going to be missing data because, ultimately the client can just go to PyPI for your package unless you're not publishing to pip at all. And so Scarf, my company, has built a free service that supplies this gateway service for a variety of different package types, Python and Docker containers, as well as files, and other packages are coming soon. And so I'm going to talk about how you can build your own, gateway should you want to access some of this data yourself. This is all going to be open sourced soon, and so I can follow up to these slides with the actual code. But the first phase of what we tried is basically just OpenResty Nginx with some Lua glue, so that we could do things like have kind of custom logic around which registries we're redirecting to, sending access logs to any kind of storage, like we're using CloudWatch in our case, and then you would just go through those logs and process them and generate whatever insights you're trying to do. As the gateway got more and more complicated, for instance, handling things like, Python's registry rewriting and those kinds of things, we are moving this code to be done more in some handwritten high-performant Haskell code, in-memory configuration, and sending access logs to like time series storage, Kafka, these kinds of things. And so because we're in the middle of this kind of moving over, the code is not yet open source, but it will be very soon. But this is a free thing for any Python maintainer to use. There's a lot of challenges to this, though, and one of them, is data privacy and making sure that the data is handled properly. But the high-level thing to say here is that this can all be done while still completely preserving end-user privacy. Depending on how you store this data, you may not need to touch PII at all. You may need to touch PII, and so our recommendations here is if you were going to spin up your own gateway service, just don't touch PII you don't need, and delete it once you're done processing it. And so in Scarf's case, we simply will process IP address metadata and then delete the IP address or store a hash of it. And so making sure that your system does this too would be an important part of making sure that you are compliant in different jurisdictions of the world. But you can leverage third-party services to do this on your behalf, so you don't have to touch the data at all. And always consult legal counsel if you're unsure. There's some other benefits of this gateway approach, which is that you can start to distribute packages from your own domain and not somebody else's. And so if the services that you're using change under your feet, you can switch them without breaking things for your users. You can switch registries on the fly. You can even dual publish to multiple registries, and when one goes down, you can switch to the other one and keep things up and running for your users at all times. Some other notable challenges with this is that while it's easy to build, it's tough to scale. You need to handle things like multi-region availability, redundancy, and that's where the real complexity really is here. The code itself is simple, the infrastructure that actually makes the service available much harder. Obviously, rigorously scrubbing that PII is something that must be done very carefully and is a non-trivial amount of work. And then there's also the issue of, just have a lot of competing package installers. You've got pip, you've got Poetry, you've got Nix, you've got all these different package managers. And so with different package managers doing slightly different things, you have a lot of edge case issues when it comes to things like how are packages pulled, how do they handle multiple indexes, that sort of thing, which can cause either incorrect counting of package downloads or, you just never see the traffic in the first place because they're not going to the registry that you are trying to get the package manager to pull from. And so overall, there are challenges to doing this, but at the end of the day, this allows maintainers to collect a lot more information about their package usage than they would otherwise be able to. So to tie this all together, one of the main points I'm trying to make here is that registry data can be very useful. You can, better understand how your software is being used, understand where, you might have commercial opportunities, understand how you can maintain your software in the most proactive fashion. Your current registry provider does not provide access to all the data that you should have, but there still are ways to get to it. And short of hosting your own registry, hosting a registry gateway can also be a reasonable option. You can build one yourself pretty easily, or you can use other free ones like Scarf. And so thank you very much for listening. You can connect with me on all the regular social channels. And if this is of interest, you can also check Scarf out for some free gateway registry gateway services as well. Thank you so much.